Our second speaker in today's seminar is Dustin Smith, who is co-founder and CEO of a company here in Charlottesville called Hum, who make AI systems that are used by academic publishers we know and love, Oxford University Press, IOP, IEEE,
AIP, SPA,
AIP, all the publishers.
Most of the physics folks we knocked out. Yeah.
And he's going to tell us about the work they do of creating AI to help publishers help researchers. So,
sounds good. Thank you very much. And sadly, I won't be talking about Alchemist taxonomy, which would have been a real natural complement to John's work, but maybe another day. So we build AI systems for publishers, and I'll talk you through Alchemist Review today, which is really talking about editorial review. So we're going to take you inside a publisher, not necessarily the most sympathetic crowd. Sometimes we get booze when we talk about publishers, and you're thinking of folks like Elsevier who make crazy amounts of money off of free labor, and sure they do that. But ultimately, what you all do in this room is you do great work. You put it out there to publishers. They mint it into published works. And that ultimately gets you things like tenure and promotion and the ability to put out grants, and it's validation. You obviously could put it on archive and just stop there, but people don't do that. I think everybody in here is probably a published author. So these are the sorts of folks that we work with on a day-to-day basis. It's important that these people exist to help with the research enterprise, to help get research out there. And this is ultimately, we obviously know that this is a linear process. One follows the other, follows the other. I'm absolutely kidding. This would look absolutely crazy if we plotted what this really looks like, the conducting of research and writing of a manuscript. That's really what happens with you guys. And then when you hit the sort of front door of a publisher, you're submitting a manuscript. You're submitting a manuscript to a manuscript submission system. You obviously have the original work. You may have data that comes along with it. There's all the metadata that goes into the system. They do hundreds of checks. These are things that you don't see. So they do hundreds of checks, and it's focused on technical checks like, is the word count right? Is the format right? And all the references. They do research integrity checks. Are you a fraudulent person? Are you ultimately submitting fraudulent research? And we'll talk a little bit more about this problem, which is huge and mounting in the face of AI. Then there's something called first decision. Internally, they will talk about it as desk reject. Obviously, externally, they don't talk about it that way, but it's basically like a big wig reads your paper and decides, is it a good fit for the journal, and are we going to advance it to peer review? And the process you know well from being a reviewer and having your paper reviewed is the peer review process, sending it out to reviewers, ultimately getting comments back and incorporating that. And then maybe after a number of months, do you ultimately get a published article? And it can be, for astronomy, I think it's 60 days to time to first decision. This is something where everybody's a little bit boiled frogs on. Should it take 60 days to get to the first decision on a manuscript? I would argue no, but ultimately that's the sort of state of affairs right now. And partially it's the state of affairs because this is a screenshot from last week. This is the software that publishing runs on. This is state of the art. These interfaces were designed in 2009, and the backend software is even older than that. Ultimately, to operate these, you need lots of people to be able to push all of these manuscripts through the system. And so they are very flat-footed in the age of AI. Ultimately, AI is being adopted by the people who are submitting papers, certainly being adopted by the likes of Google in terms of Google overviews, and they're sort of stuck in the middle. And they're stuck in the middle with some pretty intense problems that are mounting. So I'll talk about the three that are key and the ones that we're addressing with Alchemist Review. So you'd think it'd be a good thing for them to have a lot of content coming in through the front door. They're publishers, that's what they do. They actually make money off of content. So the more content they publish, the more that the more money they make. And as an industry, they make about $33 billion a year. This is really a sizable piece of the economy. And over the past 10 years, we've seen the total number of papers being published grow about 50%. So this is a curve that's already somewhat steep in their mind, and it's about to bend. And it's bending because of the sort of AI that everybody has at their disposal. And in the best case, it's really just getting good research out faster. And in the worst case, it's ultimately equipping paper mills and others to put out fraudulent research. There's somewhere in the middle, and this is sort of the newest emergent category of the kind of AI scientist. There was a company that was funded by A16Z yesterday to the tune of $200 or $300 million that is attempting to do synthetic labs and synthetic science. As you put these things together, that kind of light cone on the right side, it's unclear how steep this curve is going to be, but they're going to be seeing more submissions, certainly, if not publications down the road. And again, back to those pieces of software, if you have that much more content, ultimately you're going to have to throw more people at it. The fraud is becoming really intense. It was prior to the latest wave of AI, and I'll talk about when I say AI exactly what I mean. But I think the sort of general usage is good enough for the moment. So paper mills ultimately put out fraudulent research, and they effectively trade money for status. There's a market for this. And so in various countries, you may pay to become an author on a paper. And it looks increasingly like a valid piece of research. We were talking to IEEE recently, and we found a fingerprint of something that had 20 digital object identifiers from references that didn't resolve. This is the absolute fingerprint of a hallucinated paper. Ultimately, most of the paper was AI written. This would have made it all the way through the system. So they would have spent tens, if not hundreds of hours on this paper. It would have made it out in the world. Then they would have had to pay to retract it. And so this is happening across the industry. Really when it goes pear-shaped, that's Hindawi. So Wiley bought Hindawi for $300 million and then had to shut the whole thing down because it was rotten to the core. So in 2023, they had 8,000 retractions, pulling that back. And the fraudulent papers are getting better and better. Unpublished numbers from 2025. I'm not going to tell you which of the two publishers from that logo set, but two of the biggest publishers on the planet have cited their submissions are up 30% and their published papers are down. So ultimately, that spread is bad research. They would otherwise publish it because they actually make money off of publishing research. So they have this yawning increase in submissions that are many of which, if not most of which, are very poor quality. And again, people and old software is what they have to throw at it. The third bit, end of the world. Some of these people are way too young for that cartoon, but reviewers are lay tired. So ultimately, in most disciplines, 10 or 20% of the reviewers do the bulk of the work. So you may do this simple math of saying, okay, well, the last 10 years, we've seen a 50% increase of the total number of papers and a 25% increase of the scientists. We should be able to cover that spread, no problem. But ultimately, if it's a small pocket of people who are doing those reviews, that's a very difficult situation to be in. And so we're seeing the data from publishers suggest that the median publisher is sending 7 to 8 review requests per manuscript, and the high end is closer to 15. And so you're sending probably irrelevant invites or ones to people who are overworked. And so this is a problem where they have a long period of time where they don't have enough people to address manuscripts. Ultimately, they don't have enough people who are highly qualified reviewers to put them through the system. So our ambition is to solve all three. And we wouldn't be doing this. We wouldn't even think of be doing this 5 years or more. So this is really with AI at the core.
Yeah, but that's not a question for them, is it? Yeah. Okay. Yeah, I know. You've talked about this.
3 components here.
Matt.
Matt, buddy. The 3 components are upfront, that triage step, doing triage faster, those hundreds of things that people are doing, helping editors assess the fit and deciding which bucket they go in. Let's get this to peer review quickly. Let's get it out of the system quickly. And then also finding and inviting reviewers. So I'm going to show you some things. And I was talking to Paul briefly beforehand. This is early stage stuff where we're putting this out in the world, and our validation is less in terms of numbers and more in terms of revenue. If publishers decide to work with us, then we're doing a good enough job. And I'll show you some of the publishers that we're working with. We already talked about some of them. The only way that this is possible is using modern transformer-based AI at the core. And so we're not using the kind of classic software that the old systems, the ones that I showed you, use. We're ultimately using quote unquote compound AI systems. And so it has an LLM at the core, but it's not the equivalent of just passing a prompt to ChatGPT or a prompt in files to ChatGPT. It's a sophisticated system that has awareness of all of a publisher's users, internal and external, has awareness of all of their content, has external awareness of the entire reviewer ecosystem, for instance, a whole lot of domain knowledge, including how editors do their jobs. And this serves as a substrate. And so we build apps off of this new computing platform. One of them is Alchemist Review, and I'll show you some of the stuff that we're doing. We're doing this hand in glove if we're talking to the Brits, or hand in hand with our good partners, some of whom are mentioned, and we're very physics heavy. Obviously, I have AppJ represented in IOP and MNRAS and OUP, and they're giving us quite a bit of feedback. Editors, as we all know, brutal and direct with their feedback, so we're not short on that at all, but it's live in real-time streaming from the app. So there's a little bubble there which says what's live and what's coming soon, and we have a bunch of stuff that's about to drop. But this was originally formed, the sort of core of this app was formed with the PLP group. So this is AIP, IOP, and APS. This is the purpose-led publishing group. They're basically the ones who shake their fist at Elsevier. So we're fighting with the good guys, just in case you missed that nuanced point. And so the first component of this is LLMs are actually not very good at generating text, but they are very good at reading on the whole, especially reasoning LLMs. And so the first thing here is the digest of the manuscript. So getting in, diving and reading an entire 20, 30, 40 page manuscript and getting the things out of it that an editor would really want. So it's what type of paper is it? Ultimately, what are the methods deployed and how are they deployed in the paper? What are the key concepts that were highlighted? We have a separate product called Alchemist Taxonomy, which I referred to earlier. And so we're saying which are the taxonomy terms, and then you're able to use those for things like editor assignment. We're in the initial version doing some lightweight evaluation in terms of what are the issues and things like writing quality and readability. So it's sort of a first pass of what an editor would do if they were to read the whole thing and then write some notes to themselves. We also have a built-in chatbot. The chatbot has awareness of both the original manuscript as well as the digest itself, and you can ask whatever questions you want to it. It is tuned to respond as a colleague, so it speaks more academically than a generic sort of off-the-shelf chatbot, and you're able to answer questions. So you might have a question that it excels at, like given the research goal and the results, were the methods that were applied appropriate? And it'd be able to answer that well. There are ones which we see all the traces from the searches, and that gives us indicators of where we need to do more. People will torture the chatbots. We won't tell you exactly who does that OUP, but ultimately asking for things like, I want to review your email address. So some of the things that were coming soon are built off of the things we're learning from the early part of the app. One of the key things that were originally done by reviewers, allegedly, is look at every reference and citation. And so we're doing that automatically. So we're looking at every single reference, every single citation. We're doing a suite of checks, including, does it exist in the manuscript itself? Does the reference exist? Has it been retracted? Is it relevant? And all of these things, including metadata about it. So who are the authors and what's the author concentration? Where was this reference coming from? When was this reference published? And giving that all to the editors in a quick sort of dashboard at their disposal. And this is a way into critical issues like high self-citation rates or citation rings. Some of the things I mentioned before, DOI is not resolving, which looks like a great fingerprint for AI-generated content. And these are threads that they pull on as they are getting the manuscripts in, as they're considering them. One of the things that in the sort of summary for the talk was places in which researchers benefit. So this is an indirect thing where it's like, the more we can put on editors, basically the more we can put on robots that are used by editors, the less you have to do downstream. If all of these checks are done upstream, then you don't have to do them when you're reviewing. You're really just focused on the things that only humans are good at. So some things that are coming soon. Journal fit is one that is very much. Well, it's sort of controversial. So this is ultimately looking at the manuscript and acting as an editor-in-chief, looking at the goodness of fit with the aims and scope of the journal, and then the impact, novelty, and rigor.
Right.
So what we're trying to do is bucket these. It's okay, you just got to power through. That's it. So we're ultimately trying to bucket these where what should move very quickly to peer review, what should move out of the system, what might need to go to another journal. So it's good science, it's maybe novel and high impact science, but it's better fit for another journal. And so we can help editors do that much more quickly. And if you think of that 60 days to time to first decision, we're hoping that this ultimately speeds that. So let's get it forward or get it out much more quickly. We're also helping with the sort of front end process where we're aggregating a whole bunch of signals into what we're calling a triage center. So the hundreds of checks that you do right now, it's going through that old software and it's scrolling down and down and down and down and maybe going back and forth between the PDF. And there are humans who go in that old system and they look, every author, every institution, is this double blind? And so they're doing all of these heavily manual checks. And what we really want to do is say, these are the things that a human needs to look at, and these are the things that don't. And there may be some manuscripts that are absolutely perfect and let those sail through. And so this is really trying to guide the human attention so that you're able to, again, compress the amount of wasted time in the entire system and for individual people. We're doing things where you can talk about LLMs, but these are VLMs, so vision language models, where we're looking at figures. One of the things that human editors do is they will get a Word document or a PDF or a tech document, and they will scroll up and down, figures at the bottom, and they're looking to see if they're in the text. And this is just wasted human time. These are world-class experts. They're scrolling up and down on their screen. So we're ultimately looking to see if it's actually cited in the text appropriately, as well as some hygiene elements. So scale and error bars, labels, the extent to which those things need to be corrected by the author. Ultimately, those are placed in the triage center as well. So again, compressing the amount of time that editors are spending on those sort of things. One of the things in the studies of editors that we've done, they do so much Googling, they need a crazy amount of RAM. They will have a manuscript and they're opening tab after tab after tab, and they're looking to validate the novelty of the manuscript in question. They're also looking at so the simple quick fix here is to just give them relevant papers, which they ultimately can click out to on their own and open 5 tabs instead of 25 or 30. And we're also giving them an assessment of why we chose that. But there are some people, particularly on the sort of handling editor, and these are the people who you interact with when your paper is under review or you're a peer reviewer yourself. And those people spend so much of their time thinking about finding reviewers and inviting them. And the sort of olden way to do this is you put together a giant reviewer database, you take all of the published work out there, and you're ultimately trying to do this matching. And much of it is done off of either just abstracts or the open access research corpus. We're employing a handful of new models here. One is to pull from people who have authored in the same journal. So there's a relationship already. Some people, Ilse Cleaves, will only review for journals in which you publish, AppJ. So ultimately taking advantage of some of those heuristics. We're also pulling from reviewer lists and advanced web searches or agentic style web searches, and then fusing those together and adding an information layer on top of that, which queries some of the internal databases that publishers have. So we're compressing the amount of time for finding the right people, but also finding the information to reach out to those people. And wait, there's more. I mean, this is sales, this is industry, so fun. One of the things that editors do, the handling editors, in their systems, and this is the old software, they will basically say, I want this person to review, and then there's a button to invite, and you get this grotesque, boring invite email, which says, this is the manuscript, and would you like to review it, and whatever else, which violates all the principles of good marketing. And what we want is for you to believe that the editor cares. And does that really matter? So what we're doing is we're taking the pieces of research that ultimately informed the recommendation, and we're reformatting that into, this is exactly why we want you to review this paper, so you feel as if you are a special person in the world, and hopefully say yes. And if nothing else, then this is better for interpretability, and you can help select or deselect as part of this process. This is just some of the stuff that we have coming. This is coming in like the latter part of this year, early part of next year. But as you can see on the bottom, we're attempting to address a sort of broad set of the kind of editorial concerns here. In the questions, if you have them, we can talk about what comes beyond, particularly in the sort of future of what the actual peer review part looks like. I'm more bullish than John is. But ultimately, that's a little preview into our world.
Great, thanks, Dustin. We have time for questions. We'll start in the room.
Yeah, good. So, in the front part of it, when you were saying the first desk thing, was there stuff in there to identify and reject bot submitted or farmed papers? I missed what key aspects, and then another follow on that is you also look for papers that largely reproduce the same authors having done something.
The thin slicing, yes.
What's that called?
Thin slicing. It's how they basically, like if you have a ham, you slice very thinly.
Oh, yeah.
Same amount of ham, thinner slices. This is the industry
Same
term
bread,
for
so
it.
like
Yeah,
bread,
yeah.
lift-
Sure,
lift
bread,
ham, okay.
ham, whatever you want.
Yeah.
So this triage center will pull in not just from our analyses, but others. So there is an organization called STM, the Scientific Technical Medical Publishers Association. They have this like zero trust manuscript sharing system. So you can find, this is the first problem that you talked about. So you can identify, sometimes paper mills will submit to multiple publishers at the same time. So if you get a match, you can ultimately flag that match. The thin slicing is a slightly harder problem, which I anticipate they will be best suited to sort out. One of the biggest issues in scholarly publishing is all of these publishers have their own walled garden. And so they're big, trenchant data problems. And so you can pretty much get all of the titles in abstract, or you at least could 5 years ago. Wiley and Springer are starting to wall off all of theirs. So that makes it a little bit challenging to get to the thin slicing, which is an issue. It's just, it's more of like, that's a capital Q quality issue more than it is a research integrity issue often. I'm not in charge here.
Oh, yeah, go
Are you
ahead.
in charge? Okay, sorry. Okay, any opinion here is of my own. I might be giving some opinions. Okay, so lately, well, I was never actually a real astronomer, but now I work in the science operations sites in Alma. And we have been trying to apply data science and analytics into some of our processes. And I think as astronomers, and people maybe will kill me here, sometimes we get completely, how do you say it, when the lights highlight you?
Yeah, like lights in your eyes.
Yeah, no, but like
Story.
Like deer in headlights. Which one?
yeah, when you get headlights and you get what was it?
Deer in the headlights.
Okay, oof. Okay, so we get stuck on that, and the part of okay, let's start working with algorithms. I want to understand the LLMs, and then I want to create this paper, and then nobody cares if actually anybody is using it in practice. And if you actually did something that advanced the field or anything, is solving a problem, because as scientists, that's what most people does, no? You have a problem and you want to solve it and using your own new ideas, no? The problem that I see is that we are not seeing this other thing, that these kind of tools in many situations that we have to deal with are things that we need to work. Then we need them to work. I mean, publishing a paper of LLM that was created to create, for example, a help desk AI GPT, that at the end of the day, we cannot scale it and not use it in practice, for me, it doesn't make sense. Perhaps in the academy, it makes sense because we are doing something else. But what I don't see behind the scenes of your presentation is how is that done? I think that we don't have the technology, the base technology in terms of databases that you're using. How do you handle the creation and the operationalization of these LLM models?
Sorry,
How
you're
does
saying-
it scale?
You're saying how do they do it, and
No,
what is
yeah.
the missing ingredient that
Yeah,
we're
because
missing?
I think that we keep focusing in the academical part. The problem is that we never go to the thing that actually we need to do this thing on production, because if we are doing something for the help desk, for example, the idea was not to create a new paper. The idea was that the help desk was going to do some kind of AI intelligence that worked for the APIs.
Sure.
And I think that we're missing that part of the step where we need to consider how you build an architecture for this. What are the costs? In this case, you say that you started from a raw LLM, perhaps, or from zero, I don't know, but
yeah, I mean, so our special sauce is not in training. We do a little bit of fine tuning, but ultimately ours is in the system. So we started as a data company where we basically helped publishers understand their audiences, and then to better understand the audiences, we had to understand the content and ultimately transfer that to the people. We did that all in a private data and AI cloud, so we had to spin up all the resources ourselves, all of the orchestration. So we use over 20 different generative language models. We do train and fine tune our own interpretive language models, like how you understand content. We have other classes of transformer-based models, including re-rankers, which we use. And you have to then use these in sequence, sometimes dependent on each other, dependent on the outputs. And so it seems rather simple to like extrapolate from the kind of ChatGPT where you're uploading a file or whatever, but it's not. And so it's kind of like, we've found if we can solve these problems for lots of publishers, it's somewhat like robbing banks. That's where the money is. If I'm pitching investors and I'm talking about serving researchers, they immediately say, but they're poor. Somewhat the same for institutions. So it's like, what is the depth of the problem? And for them, you can see these like generational problems where they might not exist anymore. Or they're just being so swamped. And so for us, that's one thing. For you, it's like you can develop smaller systems. And there's also Richard Sutton, the bearded computer scientist who advances the scaling hypothesis. As foundation models get better and better, and it's sort of like the cost performance curve continues to bend, that bends in your favor, where ultimately all of this sort of scaffolding, it's like as the models get better and better and cheaper, you break a lot of the scaffolding. But then you want to do new cool things, and then you build more scaffolding around it. But as that sort of center expands, that means that you can do more without a whole lot of fancy engineering.
We should continue that discussion.
Yeah.
A couple of questions online. First, are there any questions in Green Bank or other gatherings of people I see here?
We're good.
Okay. Omar, do you want to ask your question?
Sure. I mean, I see a lot of value here for the way it was explained for publishers and reviewers, but many of these features, I think they will be very useful also for authors. And I wonder if there is a similar tool for authors. Thank you.
Yes. No, thank you. There is not currently. And it gets back to the robbing banks sort of thing. If we rob enough banks, then we can build cheaper tools for authors. But you can totally see how many of these analyses, like writing quality and readability, should not happen inside a publisher. Like the load-bearing writing quality and readability should be you as an author getting a set of pre-flight checks. Like the references side, you may have an honest typographical error. You ultimately want to fix that beforehand. So there are some tools out there like PaperPal Preflight, which is like a set of basic checks. There are some, there's reviewer 0, reviewer 1, reviewer 3, all of whom are trying to somewhat address this, maybe not as elegantly as like. So sadly, the answer for 2025 is not us. There are some others emergent, but authors deserve this too, for sure.
Thanks.
One more question. You want to ask a question online?
Sure, hello.
Author disambiguation. All right, let's do this. Do you want to, I can just, in service of time, one of the key issues is J. Smith. Actually, Chinese authors so much harder. The Smiths are pretty trivial in comparison. So we will get PDFs, and we have to start with a PDF, and we will have to peel it into its component parts, including all of the authors and affiliations, all the references, certainly all of the textual body and the built-in citations. And so you have to basically make content data out of something which is a static image. Part of that is you will see author abbreviations, you'll see et als as part of that, and you have to unpack all of that. The best way that we found to do it is to basically take the set of JSmiths. We build a sort of single or double layer graph of those JSmiths along with all of their publication record. We then create what is called an embedding. So that's basically the interpretive language model. You're taking their research, you're putting it in a high dimensional space, and you're comparing JSmith against JSmith. And JSmith in neuroscience looks different than JSmith in astronomy. And so we can then exclude the things, the sort of JSmiths there. And that's relevant for things like we're searching for JSmith. Do they have a bad retraction record? And ultimately, do you want to flag that to the editors? It's not a totally solved problem, but it's a largely solved problem where a lot of the false positives have been reduced. And you can sort of chase down the rest with human time and attention. Good question.
All right, great stuff. Well, let's thank Dustin and both our speakers again.